The structure of scientific revolutions. Kuhn was a historian of science by training and firmly believed that philosophers had much to learn from studying the history of science. Insufficient attention to the history of science had led the positivists to form an inaccurate and naive picture of the scientific enterprise, he maintained. As the title of his book indicates, Kuhn was especially interested in scientific revolutions, periods of great upheaval when existing scientific ideas are replaced with radically new ones. Examples of scientific revolutions are the Copernican revolution in astronomy, the Einsteinian revolution in physics, and the Darwinian revolution in biology. Each of these revolutions led to a fundamental change in the scientific worldview, the overthrow of an existing set of ideas by a completely different set. Of course, scientific revolutions happen relatively infrequently. Most of the time, any given science is not in a state of revolution. Kuhn coined the term normal science to describe the ordinary day-to-day activities that scientists engage in when their discipline is not undergoing revolutionary change. Central to Kuhn's account of normal science is the concept of a paradigm. A paradigm consists of two main components. Firstly, a set of fundamental theoretical assumptions that all members of a scientific community accept at a given time. Secondly, a set of exemplars, or particular scientific problems that have been solved by means of those theoretical assumptions, and that appear in the textbooks of the discipline in question. But a paradigm is more than just a theory, though Kuhn sometimes uses the words interchangeably. When scientists share a paradigm, they do not just agree on certain scientific propositions. They agree also on how future scientific research in their field should proceed, on which problems are the pertinent ones to tackle, on what the appropriate methods for solving those problems are, on what an acceptable solution of the problems would look like, and so on. In short, a paradigm is an entire scientific outlook, a constellation of shared assumptions, beliefs, and values that unite a scientific community and allow normal science to take place. What exactly does normal science involve? According to Kuhn, it is primarily a matter of puzzle solving. However successful a paradigm is, it will always encounter certain problems, phenomena that it cannot easily accommodate, mismatches between the theory's predictions and the experimental facts, and so on. The job of the normal scientist is to try to eliminate these minor puzzles while making as few changes as possible to the paradigm. So, normal science is a highly conservative activity. Its practitioners are not trying to make any earth-shattering discoveries, but rather just to develop and extend the existing paradigm. In Kuhn's words, normal science does not aim at novelties of fact or theory, and when successful, finds none. Above all, Kuhn stressed that normal scientists are not trying to test the paradigm. On the contrary, they accept the paradigm unquestioningly and conduct their research within the limits it sets. If a normal scientist gets an experimental result that conflicts with the paradigm, she will usually assume that her experimental technique is faulty, not that the paradigm is wrong. The paradigm itself is not negotiable. Typically, a period of normal science lasts many decades, sometimes even centuries. During this time, scientists gradually articulate the paradigm, fine-tuning it, filling in details, solving more and more puzzles, extending its range of application, and so on. But over time, anomalies are discovered, phenomena that simply cannot be reconciled with the theoretical assumptions of the paradigm, however hard normal scientists try. When anomalies are few in number, they tend to just get ignored. But as more and more anomalies accumulate, a burgeoning sense of crisis envelops the scientific community. Confidence in the existing paradigm breaks down, and the process of normal science temporarily grinds to a halt. This marks the beginning of a period of revolutionary science, as Kuhn calls it. During such periods, fundamental scientific ideas are up for grabs. A variety of alternatives to the old paradigm are proposed, and eventually a new paradigm becomes established. A generation or so is usually required before all members of the scientific community are won over to the new paradigm, an event that marks the completion of a scientific revolution. The essence of a scientific revolution is thus the shift from an old paradigm to a new one. Kuhn's characterization of the history of science as long periods of normal science punctuated by occasional scientific revolutions struck a chord with many philosophers and historians of science. A number of examples from the history of science fit Kuhn's model quite well. When we examine the transition from Ptolemaic to Copernican astronomy, for example, or from Newtonian to Einsteinian physics, many of the features that Kuhn describes are present. Ptolemaic astronomers did indeed share a paradigm based around the theory that the Earth is stationary at the center of the universe, which formed the unquestioned backdrop to their investigations. The same is true of Newtonian physicists in the 18th and 19th centuries, whose paradigm was based around Newton's theory of mechanics and gravitation. And in both cases, Kuhn's account of how an old paradigm gets replaced by a new one applies fairly accurately. There are also scientific revolutions that do not fit the Kuhnian model so neatly. For example, the recent molecular revolution in biology. But nonetheless, most people agree that Kuhn's description of the history of science contains much of value. Why did Kuhn's ideas cause such a storm? Because in addition to his purely descriptive claims about the history of science, Kuhn advanced some highly controversial philosophical theses. Ordinarily, we assume that when scientists trade their existing theory for a new one, they do so on the basis of objective evidence. But Kuhn argued that adopting a new paradigm involves a certain act of faith on the part of the scientist. He allowed that a scientist could have good reasons for abandoning an old paradigm for a new one, but he insisted that reasons alone could never rationally compel a paradigm shift. The transfer of allegiance from paradigm to paradigm, Kuhn wrote, is a conversion experience which cannot be forced. And in explaining why a new paradigm rapidly gains acceptance in the scientific community, Kuhn emphasized the peer pressure of scientists on one another. If a given paradigm has very forceful advocates, it is more likely to win widespread acceptance. Many